And we're live, and you're joining me today on the beach where it is sunny and warm. And no, I'm actually still in my kitchen. It's a bit disappointing. But you know, we can imagine. Makes things a little bit entertaining. How are we all doing today, guys? I'm seeing lots of us tuned in already. We've got Issa, Hamish, Freddie, I think that's Audrey, Alyssa. Good to see you all, guys. So far we're only at 8 viewers, but hopefully we'll get a few more tuning in as we go. Our plan for the day, it's a Friday. We're going a little bit more relaxed today. We're going to do a good bit of the class curiosity tree. There's some really interesting questions that have come up on there. So we'll spend a good bit of time on the class curiosity tree. Need to talk a little bit about one or two things before that, just a couple of sort of catch-up things, mainly from my class actually, because as some of us discussed in our live chat on Wednesday, we're going to arrange a meetup. So I'm going to let people, not a physical meetup, a virtual meetup, and I'm going to do it by reading groups. I'm going to let everyone know about that in just a wee bit. We're going to do the class curiosity tree. We're going to talk a little bit about space, because you've done a couple of topics on space now, and hopefully some of that has been quite surprising to you. And I'm trying something else on my computer today that might completely break my system, because it's quite processor heavy. It's asking my computer to do a lot of things at once, to be doing a live stream and running this other piece of software. But we will try it. We'll see if we can get it working at some point. Anyway, let's just have a quick look at the live stream. Yep, we're up at 19 viewers now. Am I jumping about all over the place just now? How's my how's the connection? Am I really slow and jumpy and glitchy, or not that bad? I'm seeing people saying lag. How many of you are experiencing some sort of lag? Really glitchy. Yeah. That so that's not the internet connection. That's because I'm running this other piece of software. What I'll do is I'll try and close it just now then, because like I said, it's hammering my system. My computer's not that fast, so we'll close this down for the time being. That should be now getting a wee bit better. Hopefully that's a little bit less glitchy now. We'll find out in due course, but yeah, I can hear my computer whirring away in the background, which shows that it's obviously having to work pretty hard. So the thing that I was going to show you might not work that well. We'll see. Anyway, before the class curiosity tree, a little bit of admin stuff. I'm just having an error message coming up, so maybe it is my internet connection. You never know. Okay, so there was a suggested word of the week. I know we didn't do a word of the week this week officially, but Callie suggested a word of the week on Wednesday, and I said I would mention it in today's live stream. So that word of the week is tangible. Tangible. I'll type it up in the comments just now. Here we go. So tangible. If something is tangible, it's real, it's touchable. You could hold it in your hands. So tangible things are kind of real things. But you can also sometimes kind of use it to describe ideas that are really concrete or really real, really easy to imagine. You can make if something is really easy to imagine, it's more tangible than something that's harder to imagine. So it's quite a good word. Thank you, Callie, for contributing that. Because it's a really good word for us all to use. And I know we're doing it seems a bit daft doing a word of the week on Friday, but there we go, that's what we're doing this week. Very quickly, the meetups then. So hopefully we've got quite a few people from my class tuning in at the moment. Obviously, we've got 5 reading groups in our class, and I'm going to ask you to meet in your reading groups on Monday and Wednesday. I'm going to do 3 groups on Monday, 2 groups on Wednesday. Wednesday, or did I say Tuesday? I think I've written down Tuesday. I think I mean Wednesday. Um, yeah, Wednesday after the live stream. So, the three groups that are going to meet on Monday are going to be the Race Against Time group, the Dodos Are Forever group, and the Huntress of the Sea group. That's on Monday, and we're going to do that after the live stream. It'll probably be about 20 minutes per group. So just kind of lurk about on Teams and look for your team meeting coming up. I'll schedule each one for 20 minutes. So we'll do one at 11, one at 11:20, one at 11:40. And that'll take us up till 12. And then on Wednesday, it's going to be the Windscape group and the Parvana's Journey group. So that's what we're going to be doing on Monday and Wednesday. So please turn up to those meetings. We're not necessarily going to talk about the book. We're just going to talk about other aspects of learning. Okay? Right, class curiosity tree then. No, if you're not in my class, you won't have any of those books. This is for my class only. So don't worry if you don't have those books. No, this is just a P6B thing at the moment. And yes, Rosalind, we are doing a Philosophical Friday after this. Anyway, let's get cracking just now with a bit of the class curiosity tree. So, some really fascinating questions coming up there. And forgive me, I've only really browsed my class's class curiosity tree. I'll try and look at the other two classes in the next few sessions. But question one, I think this one was from Lucy. How can sailors navigate using the stars? I'm not going to tell you that exactly just now, because it's actually part of a lesson we're doing. Maybe next week, maybe the week after. I can't remember exactly when I've planned for that. But I've already typed up the lesson. It's ready to go, and you're actually going to be trying it. But to give you a rough idea, there is one particular star in the sky called Polaris, and that is over the North Pole, hence its name Polaris. And Polaris doesn't move, or it doesn't appear to move. It stays completely at the one place in the sky, and all the other stars appear to move around it. So if you can find Polaris and then look down at the horizon, you then find where true north is. And so if you know where north is, you turn 90 degrees one way, you've got west. You turn 90 degrees the other way, you've got east, and so on. So that's how sailors can use the stars to navigate. There's other things that you can use to navigate as well. And in fact, I know Archie has been reading this book in my class. I think it's a fantastic book. It's called The SAS Survival Guide, which to me makes it sound a bit, I don't know, just a bit juvenile. But actually, it's a genuinely good book for sort of survival stuff. And it gives you lots of other ways of navigating and finding different directions. So, cool book to look into if you're wanting. Are people still finding that there's issues with the connection at the moment? Let me know in the comments. I'm going to keep going just now. If there's problems with me glitching and stuff, please let me know, because that shouldn't be the case now, and I'm surprised if it is. No, people saying it's fine. Okay, thank you. Right, next question. I need to probably go a wee bit faster because there's quite a lot of these. Why do flowers have a smell? Is it pollen or not? And that's from Freya. Part of a flower smell is from its pollen. However, flowers and other plants put out lots of other chemicals, not just pollen. There's one flower, and I can't remember its name. It's often just called the corpse flower, and it actually smells of rotting flesh. The reason for flowers each having a fairly unique smell is to attract the pollinators. Now, some of those smells smell nice to us, but the organisms that those flowers smell really, really nice to are the things that are meant to pollinate them. So bees, I'm trying. And I was going to say aphids there, but not aphids. Hoverflies. All the in some cases dung flies and flesh flies going to them. So when flowers have a smell, it's not really to attract you. It's just by chance it happens to smell nice to you as well. It's really to attract the pollinators, the ones that are going to be fertilizing the different plants or pollinating the different plants. Speaking of fertilization, chickens lay eggs and we eat the eggs. what happens to the chicks? Well, you might almost think this is going to be a sad answer, but thankfully, in the case of most of the eggs that we get, there's basically never going to be a chick in that particular egg. So hens lay eggs anyway. Domestic hens, domestic chickens, they lay eggs quite regularly. In fact, almost daily in some cases. The only way that a chick will grow inside them is obviously if a male chicken is there, a rooster or a cock. And so if the male chicken obviously fertilizes the female chicken, then there will actually be a embryo, a baby chicken, growing inside that egg. However, most of the time, farmers don't allow that to happen because it's better to leave the eggs unfertilized, and therefore you can sell the eggs. But yes, if there was a sperm that met the egg, then obviously, yes, there could well be a chick growing inside it. But that doesn't happen for the most part in eggs that you buy off the shelves. What is space made out of? I don't know why I've written this one down, because frankly, we don't really know the answer. Or certainly the answers that we think we know, we don't absolutely know, and so it's kind of hard to answer that one. If you're talking space as in outer space, well, it's made of lots of things. It's made of empty space. It's made of dark matter and dark energy. Now, those are weird things that we're not even really going to get into in this space topic, but there are things called dark matter and dark energy, or we strongly believe there are, but we've never seen it, and we've detected it, but we've never seen it in any sort of way. And then, of course, you've got regular matter, so hydrogen, helium, and antimony, and arsenic, aluminum, selenium, and hydrogen, oxygen, nitrogen, rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, and so on and so forth. All of that stuff is what the rest of space is made of. In terms of space, like the stuff that's around us, it's not really made of anything. It's just a property of the universe. However, we do know that it's being forced to get bigger. So space around you right now is stretching, which is a hard thing to contemplate. But right now, the space around you is stretching. You just don't notice it's happening because you're being held together by your molecules and gravity and all that sort of stuff is holding you all together. But space right now is stretching around us, and that's being driven by something called dark energy, which we don't know what it is, but we think it's real. We're fairly sure that it's real. Mind-melting stuff, though. You guys, if you become the scientists that figure this stuff out, please come back and explain it to me when you're older. Because I've read a fair few books on this stuff, but even then I've got a very amateur understanding. You guys, you may well go into some sort of cosmology or astrophysics or something. Come back and explain it to me if any of you do that. Okay, next wee question here. What chemical elements are rock and steel made out of? Well, steel's easy. Steel is what's called an alloy. And alloys are basically mixtures of different metals. So if you melt down lots of metals and then just, I'm simplifying it a bit here, but melt down lots of metals and let those melted metals slosh together, you've then got what's called an alloy. Now, the main metal that's in steel is iron. Steel is an alloy of iron and then some other metals to make different types of steel. Sometimes not just metal, sometimes things like carbon as well. But that's what steel is. Rock, well, rock isn't just one thing. There's lots of different types of rock. So there's always lots of different elements inside rock. You're talking things like carbon, hydrogen, oxygen. Silicon is quite a common thing inside rock, but also metals as well. Some rocks have uranium in them. Lots of rocks have iron in them. So it's not really just, you can't just say that rock is just one thing. It's made of one element. It's absolutely not. It's made of lots of elements and lots of different elements in different situations. But a good question. Why is fire orange, red, yellow, and blue? Well, we kind of did this when we did our chemical reactions thing, but you may not remember it. So when we did chemical reactions, remember I made a whole load of fires on the desk and they were all different colours. So if it had things like sodium in it. Sodium makes a really sort of yellowy orange flame, really quite a vibrant flame. You may remember that I put borax in it and it went a really, really bright orange color. So that that's one of the things that can change its color. I think potassium permanganate, that makes it a purple flame. Copper, I'm going to say copper sulfate. It's not copper sulfate. Copper chloride, that makes it a bright green color. So basically, fire is the color it is because of the chemicals that are burning inside it. Hopefully that kind of makes sense there. I'm seeing my shoulders are being cut off here. I'm trying to figure out what side I need to be on in order for my shoulders not to be cut off. I think it's this side. Yeah, there we go. I've ruined the green screen illusion. What a shame. Okay, just a couple more of these quickly. What was the first type of plant? Almost certainly something even simpler than an algae. So it was probably just a tiny wee cell floating about in the water. But it learned to do something very, very special, and that's called photosynthesis. So photosynthesis is when it's taking light and using a chemical called chlorophyll, turning it into energy. The first plant to do this will have been a very, very simple thing. It would not have been recognizable as a plant. It wouldn't have had leaves. It wouldn't have had a stem. It will have just been basically a little cell floating about in water, looking like all the other cells. But it had learned to it had not learned, evolved to photosynthesize. In terms of the first recognizable plant, I'm guessing here, but I'm guessing things like, well, algae, proper algae growing. Then you've probably got things like seaweeds. Seaweeds would be next because most life kind of started in the seas, and from there it emerged out. So you'll have had things like seaweeds. And dominating the world for a very, very long time were ferns. It took a long time for things like wood and flowers to actually evolve. So actually, flowers are relatively new in evolutionary terms. They're still millions and millions and millions of years old. But for a very long time, things that are called angiosperms, things with flowers, didn't exist. It was things like ferns for the most part. This one's from Ellie here. Have scientists / people that study the universe found out if parallel universes are real? Maybe. Maybe. So, first of all, you need to know what the universe is. The universe is everything. So, every star, every galaxy, everything all together, that is the universe. So, if the universe is everything, how could there be other everythings? Well, it's actually a possibility. And in fact, one theory about the universe, which is called string theory, says that there has to be other universes, which is kind of crazy, or kind of other universes, other dimension. Yeah, no, I think it is kind of other universes. There's certainly 11 spatial dimensions, according to, and that's really complicated. But or is it 10 spatial and 1 time dimension? I sometimes get. I haven't read any string theory or quantum physics for a while now. But string theory and some other theories demand extra universes. They say that it has to be real. And basically the maths, you can prove, the way we understand the universe is using maths. The maths seems to indicate that there probably are, or possibly are, other universes. But would we have any way of interacting with them? No, they'd have entirely different laws of physics. They would probably work completely different to us. But it's an interesting concept, nonetheless. Okay, what color was space before the Big Bang? What do you mean before the Big Bang? In fact, well, I'm going to say possibly now based on new research that came out in the last few weeks. But there were 2 things that the Big Bang started with. Space and time. Therefore, if time started at the point of the Big Bang, there was no before, because time hadn't started yet. And that is something that's like mind-melting. But yeah, space and time are joined together. So if there's no space, there's no time. We think of space as being one thing and time as being another thing. They're not like that. Space and time are joined together. You can't separate the two. And so before the Big Bang, there was no space. That means there was no time either. However, oh, and I can't remember the name of the researcher. I feel like it's going to be is it Penrose? But in any case, there's a famous cosmology researcher, and his name escapes me right now. But he's a big advocate for the idea that our universe has gone in cycles. So there's a Big Bang, and then everything fades out, and then there's another Big Bang, and then it contracts again. And we're just in the latest cycle of the universe. This has perhaps been going forever, which I think is quite mental to contemplate. Last one just now then. This one's from Rosalind. If we all had the same life experiences, would we feel the same way about everything? No. No, we wouldn't. Because only part of the way we feel about things is formed by our upbringing, by our life experiences. So some people like to believe that, oh yes, everything is about upbringing. If you raise someone just right, you can turn them into anything. But we know that that's not really true. I made this joke to my class before. If I take a child, if I took a child right from birth and raised them just right, no matter what, I'd never manage to make them into an adult squirrel. They would never develop all the properties, all the characteristics of a squirrel if I raised them exactly as a squirrel. Why is that? Well, it's because of our genes. We have genes that make us different as well. So a lot of who we are as people, and a lot of what we believe as people, a lot of the opinions we develop as people comes from our upbringing, the way we're taught, the way our parents raise us, the way your teachers raise you. All of this stuff contributes about 50% to the way you are and the way you feel about things. But the other 50% is to do with your genes. It's to do with some people have genes that might make them feel a bit more stressed under certain situations. Some people have genes that might make them want to challenge things a bit more. I think I'm a bit like that. I see if there's something I disagree with, some people will just say, okay, right, we disagree with that. And I'm one of these people that says, no, we're going to have a fight about this now. No, let's have an argument. And part of that is driven by your genes. It's the way your genes have grown your brain, the way your genes, your DNA drives your personality. So you are 50% roughly your upbringing, and you're 50% roughly your genetics, your DNA. So even if we raised everyone identically, absolutely identically, there would still be huge differences between us because genetically we're all different, which I think is kind of cool. Right, that's your class curiosity treat. Sorry if you can hear my kids shouting in the background just now. We've got a film on, I'm trying to distract them. But hopefully you found that quite interesting. Anyway, space. Yesterday, I think it was yesterday, were doing stuff about space and you were comparing the size of different planets. So in the instructions, you were told that you were to imagine that the sun had been shrunk down so it was about the size of you. So from your feet all the way to your head, most of you are probably about 140 centimeters. Some of you a bit smaller, some of you a bit taller. But 140 centimeters is probably, going off the top of my head, an average-ish size for you guys. So I want you to imagine that the sun is a sphere as tall and wide as you are. Okay? Or as tall, as wide as you are tall. So quite a big sun there. You then had to sketch the relative size of each one of the planets. What I want to know is what surprised you there? Was there anything that surprised you? Type in the comments. I know Audrey responded earlier basically saying that one of the things that surprised her was that all the planets were different sizes. I think that's one. That is quite surprising. You know, maybe in some diagrams you're used to seeing the planets being shown as roughly the same sort of size. They always draw Jupiter and Saturn as a bit bigger, and Earth and Venus as a bit smaller. But yeah, Nathaniel's saying it here. Earth really is tiny. I mean, we're really, really small compared to the likes of Jupiter or Saturn. I mean, Mercury, that's the smallest of the planet. I mean, that's really just a speck compared to all the other ones. But yeah, I think there's something quite phenomenal about that. So every diagram that we've ever seen, we're shown these diagrams all the time about, in fact, I can probably get one up quite quickly, but let's type in solar system. There we go. We'll get a, hey, here we go. A nice easy one. I'll pull this up in just a minute for you guys. But we're shown diagrams of space all the time. And they usually, let me make this one a wee bit bigger here. Yeah, diagrams of space, more often than not, look a little something like that, for the most part. So you see the sun being a bit bigger, and then all the planets being quite close and a bit smaller than the sun, but not hugely. How wrong is the scale of this diagram? I mean, it is... There's just no comparison. The sun should be much, 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 much bigger, and all of the planets should be much, much, much smaller. One other thing that's quite cool, actually. Here's something that I think hammers at home, and I wish I'd pulled this up sooner. How many Earths can fit in the sun? Let's see if the diagram I'm looking for comes up. Here we go. So this is a model that someone made showing just how many Earths would fit inside the sun. I think this is mind-blowing, staggering. So that whole sphere is supposed to be the sun, and you can see it's just full of thousands and thousands and thousands of Earth-sized balls. That shows just how small our tiny little Earth is compared to the whole of the rest of the universe. And yet, all of the diversity, all of the wonder, all of the majesty that we have ever experienced in our lives has occurred on that tiny little rock. And I think there's something quite wonderful about that. So that's something that's kind of cool. That's how many Earths can fit inside the sun. That's how small we are. I hope you guys find that as amazing as I do. I find this stuff like, oh, just mind-meltingly fascinating. I absolutely love that stuff. And I hope you guys kind of do as well. So what you should have figured out already are two main things. One is that our Earth is really, really small, basically, compared to all... I mean, it's still big enough to house all of us. It's 6,000 or 7,000 kilometers across. Is it more than that? I'm getting myself confused there. No, sorry, 1 point, that's its radius. I think it's 1.4, 1.3, 1. What would that be? 13,000 kilometers across, yeah. So it's still big enough to house all of us, but compared to something like the sun, there's just no comparison. Just madness. But the other thing you should have learned is that most of the diagrams that we're shown don't do space justice. And that's not anyone's fault. It's just you can't show diagrams accurately, in a way that you can basically you wouldn't see the diagrams if they were accurate because the things would be too small. That's what I'm trying to say. I'm getting a bit rambly there. Anyway, the last thing that I'm going to do with space with you guys just now, I'm going to close this down for the time being. Nope, we'll close all that stuff. Which means that this is probably all going to glitch out just now. And we're going to try something a bit different. You might hear a whole load of audio coming up, and I'm probably about to go really, really glitchy. So I apologize about that. But I'm going to pull up a different piece of software, and the sound usually absolutely blares when I do this. So I'll need to turn off the sound for a wee moment. until I get this sorted. Hopefully that's loading up. Here we go. Right. So this is something called Universe Sandbox. And Universe Sandbox is basically a simulation of the way the universe works. So you can look at lots of different things, and you can run little experiments. You know, you could see like what happens if I make the sun 10 times bigger. What will happen? What will happen if I make Earth 10 times hotter? What happens if I smash these two planets together? You can do all sorts of weird and wonderful things. And I apologize just now if I'm glitching all over the place. In fact, I can see that I kind of am a little bit. So sorry about that, guys. However, this is Universe Sandbox, and you can see that we've got this solar system in the background. Even if I'm hopefully you can still see the audio, even if things aren't moving very well. But if I go, let's click on, first of all, we're running the time really, really fast. Every second here is 2 weeks at the moment. So I'll tell you what, let's get Earth coming back around, and then we'll slow the time right down. Let's bring Earth just a wee bit further round. There we go. Right. Okay. And we'll pause it there. So here is Earth. And there's the Sun, Mercury, you know, we can see all these different planets here. Now, I'm going to try and zoom in on Earth. Let's see how long it is before we actually notice Earth becoming visible. So, backed up for a moment there, but still zooming, still zooming, still zooming, still zooming. I'm going to zoom for a long time there. And considering that just about now we can just see the speck of it, there we go. We're suddenly zooming into it, and we can see it now. But there we go. There's Earth in all her majesty. So moving around here, you can see just how far we are away from the sun. We're used to the sun looking quite big in the sky next to us. But actually, the reality is, it doesn't actually take up very much of the sky at all. The sun is surprisingly small in the sky, and for it being such a big object, well, that's a bit staggering. Which means that, well, that basically makes the point that we are really, really far away from the sun. Now, I don't know. I'm half tempted to go over this a wee bit now. I'm just going to touch on it. You guys should know from, I think it was all the way back in primary 1 or 2 that you last did space. You guys should know the difference between day and night and why that happens at the moment. But basically you can see, because the Earth is spherical, or an oblate spheroid is the proper word, you can see that obviously you can only have one side pointing towards the sun at one time. So at the moment, this would be, we are about there. So this would be getting towards nighttime for us, but you know, maybe getting towards sunset shortly. It would be late afternoon at the moment here. Oh, actually, no, it wouldn't. It would be early morning because the Earth spins the other way. But right now, you can see the likes of Africa and Asia, Africa, most of Asia, and Europe are in full sunlight. Whereas if we were going to go around to America, most of the United States would be in darkness at the moment. So that's the difference between day and night. Okay? And that's stuff that you should kind of know already. So you should know that a day is the amount of time it takes for the Earth to spin once, to rotate once around. So if I play this again here, we've got 4 hours a second here. And you can see the Earth is spinning away. And that's how our days happen. Now the thing is, all other planets have days as well. If we go to, let's zoom in on Mercury now. Obviously Mercury has days too. But you might notice that its days are a little bit different to ours. Let's just wait for it to zoom in. Actually, I've chosen a bit of a featureless planet, so you might not see it spinning very well here. But if we press play on this, you'll see it doesn't really appear to be spinning at all. Helps if it plays. Here we go. There we go. You can see it's spinning really, really slowly. So Mercury's days are way, way longer than us. Now, it's probably going to take too long to get out to Jupiter for the purposes of this video, but if we can find Jupiter somewhere, you should find that Jupiter is really quite the opposite. Jupiter spins really, really fast, despite being a huge planet. It is spinning at a speed that just standing on Jupiter the wind speeds would rip the flesh from your bones, probably. It's spinning at an astonishingly fast rate. We'll hopefully see that as we zoom in here. But Jupiter is just whizzing around much, much faster than us, which I think is kind of cool. Yeah, so you can see we're spinning much slower compared to that. You can see if this is we've got 1 second is about 3-4 hours here. It's basically having a day every few hours, really, which is just crazy. So anyway, I'm going to stop that simulation there, but hopefully that kind of makes the point of the scale of our solar system a wee bit more. And that's what the sun would look like and that's how far away the sun looks from Jupiter, which is kind of cool. One last thing we can do, actually, you can see the difference between all the different planets side by side there. So if we were to put them all directly side by side, first of all, they would all be scorched by the sun, because nothing gets that close to the sun without dying. But that's quite a cool comparison of the different planets there. We have Jupiter being about 1/10 the size of the sun, or 1/10 the diameter of the sun. But then all these other planets here, oh, that's a dwarf planet, Eris. I can't actually get Earth. There we go, Earth. No, that's Iris now. So many other wee dwarf planets in our solar system, which kind of makes the point, because you're used to hearing about the 8 planets, and you've probably heard about Jupiter as well, the dwarf planet. But you've actually got all these other things as well. We've got Eris, we've got Iris, we've got various different moons. I think there's Ceres as well, should be there somewhere. So yeah, lots of other things in our solar system, not just those planets. And yeah, I can see how glitchy it is, so I'm going to close this down just now. Sorry guys, I've just noticed all your comments in the background just saying how laggy it is. So I'm closing that piece of software now, but hopefully you can see what that's like there, which is kind of cool. Should be coming back to normal speed now. Does the audio go when it gets laggy as well? Or is it just the sound? Sorry, is it just the visuals? Hopefully you can lagging like cuckoo. I've never heard that before. Anyway, guys, that is pretty much everything that we're going to go through just now. I've been at this for about 40 minutes. Lots of me just spraffing away. Let's go back to the beach before we finish up. But yeah, there we go. That's our lot for today. Hopefully you learned a little bit more about space. But basically, planets are vastly different sizes. Audio's fine, Rosalind's saying. That's good to hear. And yeah, I love space. I think it's fascinating. Some of the activities that we're going... Oh, internet safety. I did say we would do internet safety. Very quickly then, there was only one point I wanted to bring up. Now, lots of you were coming up with really sensible rules about internet safety, and that's really great to see. One of the rules that came up is that quite a few people said is you should never share your personal details online. Never share personal details. Well, actually, I can think of quite a few personal details that I've shared online. I've shared, in some cases, my name, my email address, my home address, my credit card details, or my debit card details. I've shared all that stuff online. Does that make me an idiot? Am I just an internet noob that didn't know not to share that stuff? Or is there actually sometimes a situation that you can share stuff like that? And how would you know that it was a situation that you could share things like that. Type it in the comments if you can tell me when you would actually, how you would know it was safe to share those details. So when would you be able to share those details and know that it was probably safe to do so? What would be your indicator? So purchase stuff, but how do I know it's a safe website to purchase stuff from? Because I could, I've had a website in the past. I could easily set up a website that asks, says that I'm totally going to send you something as long as you enter your credit card details. There you go. So Jessica's got it in one. When you have a little padlock. So if you look beside your URL bar, where you type in web addresses, next to where it says often, in fact, Issa's also hit it in one here. But yeah, beside any website, if it's a safe website, you should see two things. One, you should see a little padlock. That means that the whole website is encrypted, and so any details that you enter there shouldn't be viewable to people at the other end. But number two, it should say HTTPS, S for secure. If it has that S for secure, you know that you're on a secure website, and so you could get away, or it is safer. Nothing's completely safe online, but it is safer to enter details that you would normally not share. But if it's just talking to someone, or if it was a website that didn't have the padlock or HTTPS, then that wouldn't be safe to share your details. Anyway, that was the last wee thing I wanted to touch upon. I'm going to sign off just now, and for my class, we're going to meet up on Teams for just a quick 10-15 minutes for a little bit of a Philosophical Friday. So signing off just now, guys, and I'll hopefully see many of you for our Philosophical Friday over on Teams. Don't feel you have to make it, but if you fancy it, it's going to be there. Cheers, guys!